Hey folks, law of sines, law of cosines. So here's the beauty of the law of sines. So if you remember last unit, last section, I said unit, I meant section. Last section, we talked about adding some angles to our toolkit of angles that we're able to find an exact answer to in the unit circle. The law of sines and the law of cosines also opens up our toolkit because the law of sines works for any triangle. SOHCAHTOA works for what kind of triangles? Well, they have to be right triangles. In any triangle ABC, sine of an angle over its opposite side is equal to sine of an angle over its opposite side is equal to sine of. So the ratio of the sine of the angle over its opposite side is equal from any angle's perspective. Now let's do a quick reminder of how we identify the pieces of a triangle. So I'm just going to draw some random triangle here. I'm going to call this big A. I'm going to call this big B. I'm going to call this big C. The angles are represented with the capital letters, and then little a is the side that's opposite the angle A. Little b is the side length that's opposite angle big B, and little c is the side length opposite angle big C. So solve the triangle with little b equal to 27.4, big B equal to 28.7, and big C equal to 102.3 degrees. So let's talk about this terminology. To solve a triangle means that you have to identify all sides and all angles. So let's make a little chart. Big A equals, big B equals, big C equals, little a equals, little b equals, and little c equals. And I like to use the same color for the givens. So they gave me that little b is 27.4. They told me that big B was 28.7 degrees. Don't get lazy. If you don't put the degree symbol, you mean that you're in radians. 102.3 degrees. Okay, now we need to figure out what's big A, and little c. And we set that up using the law of sines. Well, actually, I'm going to do something first. What's the easiest letter of this to figure out? What's the easiest piece to figure out next? Well, hopefully you said big A, because we know that all the angles in a triangle add up to what? 180. So if I take 180 and I subtract off 102.3 and then I subtract off 28.7, 49 degrees is what's left over for big A. Now from here, I'm going to set up two law of sines equations to find big A and then find one for big C. So let's set up, let's do little a first. So it's sine of the angle divided by its opposite side. So sine of 49 degrees over little a is equal to sine of, now from here I want to pick an angle who I know who has its opposite side given. So I don't want to pick big C because I don't know what little c is. We always have to pick one of these where we know both the angle and the side. So 28.7 degrees over 27.4. All right, now we need to talk about how to solve this. You've done these back ever since at least Algebra 1, probably middle school too. This is what we call a proportion. We got a fraction equal to a fraction. The easiest way is to cross multiply. So if I want to get the a off the bottom over here, I would times both sides by a. The a on this side would cancel, and it would just end up in the numerator over here. And then at the same time, I would times both sides by 27.4. So the 27.4 would actually cancel out but end up on the other side. So our equation would now say 27.4 sine of 49 degrees would be equal to a times sine of 28.7 degrees. All right, who's keeping little a from being by himself is sine of 28.7 degrees, which is connected by mult, which I'm going to kill with division. And then from here, I'm going to need my calculator to finish this. So let's see. I'll do fancy calc. 27.4 sine of 49. Oop, before I hit enter, as soon as I saw that, that made me think. As soon as I saw that degree symbol, check your mode. Good, I'm in degree mode, so my calculator is thinking in degrees right now. Now quit back, and you should be able to just continue. So sine of 49 over sine of 28.7. Turns out to be 43.06. I'm going to round to 1 decimal place. And this just because the table gets so crowded. So 43.1 is the length of little a. Now we're going to do the same thing, but we're going to do it for little c. Let's have you pause here. This will be the example that you do on your own. All right, let's see how you did. So first of all, your setup is sine of 102.3 degrees over little c is equal to sine of, now look, you do have a choice of using the a's or the b's. I recommend the b's because you rounded little a. And whenever you use a rounded value in your calculation, that means that your next rounded value will be even farther off from the right answer. So you could use this, but it's going to, unless I recommend, I'm going to tell you, use the ones that are given. How about that? Now we're all following the same set of standards. Over 27.4. I'm going to solve this one just on my calc. I don't need to. So I'm going to multiply that across. I'm going to multiply that across, and I'm going to divide by this. So I'm going to do 27.4 times sine of 102.3. Then I'm going to take that. I'm going to divide it by sine of 28.7. We get 55.7. Yep. There we go. 55.7. Which then we can box that in and put it up on our fridge. Example 2, solve the triangle with blah, blah, blah. So solve the triangle means find all the sides, find all the angles. So the first thing I'm going to do is I'm going to identify my little table again. A equals, B equals, C equals for the angles, and then A equals, B equals, C equals for the sides. I'm going to put the givens in with that color. So 15 is little a, little b is 25, little or big A is 85 degrees. All right, this time our hands are tied. We must go after big B here. We can't go after little c. Now, some people, including myself when I was in high school, would use the Pythagorean theorem to find little c. I mean, that makes sense, right? A squared plus b squared equals c squared. Why is that no good here? Because we don't know if this triangle has a right angle, and it certainly doesn't look like it does. If this is 85 degrees, we don't have much. We have to split those two angles. I mean, it's possible, but it's not very likely when we have such a big angle for one of our angles that we'd still have a 90-degree angle in there. So I'm going to go after big B. So that would be the sine of big B over little b equals sine of 85 degrees over 15. So we've got to solve this again. Who's farthest away from big B? So this is a little bit different than the orange problem, because in the orange problem we had A on the bottom. So our first move was to cross multiply to get A to the top. In this case, we're just trying to get big B by itself. So the farthest thing away is 25. So the next thing I would do is multiply both sides by 25. So I would have sine of big B equals 25 sine of 85 degrees over 15. And now, and we haven't talked a ton about this, but what's the thing that kills sine? Most of you guys remember it. Sine is canceled out by sine inverse. So whenever I want to kill just sine, I do sine inverse of both sides. So, okay, I go to my calc. I'm going to do the sine inverse, second sine, of the fraction 25 sine of 85 over 15. Whoa. Domain error. Did I type something in wrong? No, I didn't. And that's what I was talking about earlier about this 85 degrees and why it doesn't. I knew when I looked at this that I was probably going to not have this triangle was probably not going to be possible. And let's think about why. Look at what this is saying. So I only have 180 degrees to use for the angles of a triangle. We've used up 85 of them. So 180 minus 85, that leaves me with 95 degrees left over for these two angles, big B and big C. Also notice that little b is significantly larger than little a. So that means that the angle opposite, so if I have an angle, the bigger the angle, the bigger the opposite side. So how far apart my thumb and my pointer finger is, if I have a very small angle, the bigger the angle gets, the farther apart my thumb and pointer finger get. So if I have a big side, then I should have a big angle. So 15 is 85 degrees. Well, 25 is much bigger than 15, which means this angle needs to be much bigger than 85, but I only have 95 degrees left to fit with that angle and that angle. So triangle, not possible. It's impossible for you to draw a triangle that has one side as 15 with its opposite angle being 85 and then any of the other sides being a length of 25. It would be a triangle that just wouldn't meet. So here's this. Let's say so here's my triangle. Here's the two sides. No matter what, when I take this other side, there's no way that I could draw this triangle. If this is the other side, it's not long enough to go and reach that other side of the triangle. So this triangle is impossible. So weird stuff is going to start to happen. And the rest of these examples are all ones where if they only give you one angle, weird stuff happens. So in this case, they gave us big B and they gave us big C. Very straightforward. There's only one other angle, and then you can set it up. You're always going to get a nice answer of a triangle. Now down here, when they gave us only one angle, one of the situations is you could get a triangle that's impossible. Then we're going to look at the situation where it's something called the ambiguous case. All right, so let me show you what I'm talking about. Solve the triangle. So right away, I'm going to solve. Now I'm going to give you a hint here. Write your A, B, and C fairly small here. Big A, big B, big C, little a, little b, and little c. So what do we know? We know big A is 33 degrees. We know little a is 6, and we know little b is 10. So our hands are tied. We don't have a choice. Who do we have to go after? We have to go after big B. So I'm going to set up a big B equation. Sine of big B over 10 is equal to sine of 33 degrees over 6. I'm not going to show my work here. I can do this in my head / on my calculator. So I've got who's farthest away from big B is 10. So I'm going to multiply 10 times sine of 33. Then I'm going to divide that by 6. Now I need to kill off sine by doing sine inverse. So sine inverse, and then remember the answer button. Second negative is the answer button. That takes your last answer and puts it in. So I'm sine inversing that result that I got last time, and I get 65, let's call it 65.2. So big B is approximately 65.2, and now this is an angle, so we want to make sure that we call that degrees, 65.2 degrees. So now I can go over here, and I can call this big B is 65.2 degrees. All right, yay. How could you find this? You would then subtract, and then you would set up a law of sines to figure out what little c was. You box it and put it up on your fridge. The problem is you'd still be incorrect. Now, this goes back to this idea that sometimes there's solutions that aren't obvious. Like, what's the solution to x squared equals 16? We would square root both sides. We would get x equals plus or minus 4. Both of those answers are legit. Both of those answers are legal. It turns out that sometimes when we do the law of sines, we can get more than one answer that actually works. So remember, if you look back at this example, we had a triangle with a 33-degree angle. That's all we knew, is there's a 33-degree angle. We knew the side opposite the 33 had to be a length of 6, and then some other side had to be a length of 10. Well, here's this length of 6 with an angle kind of pushed in, and I get a legit triangle. So this triangle right here is a possible triangle. Or I could take that 6, that side of that's a length of 6, and I can push it out the other way and extend this length called little b, or no, sorry, this would be little a, and I would get another triangle that's legit. Both of these triangles are possible. We don't know which one is the correct triangle. That's why we call this the ambiguous case. It's ambiguous which one is the right answer. So how do you know when you have to do the ambiguous case and when you don't have to do the ambiguous case? Well, the easy part is when they give you two angles. You'll never have to do the ambiguous case when you have two angles. If there's given two angles, game over. There's no ambiguity. So we finish this orange problem, done. Things get weird when you have only one angle. You could get a situation where the triangle doesn't exist. It's not even possible. That one's all done. Or you can get this scenario where we have to check for ambiguity. So that means we now go over here, the ambiguous case. Ambiguous means we just don't know which one is the right answer. There's uncertainty. So how do you figure out the ambiguous case? Well, what we're going to do is we're going to find, because sine inverse, remember we did sine inverse? And sine inverse, wait, is that a better way to explain it? Think about this. If I said solve an equation with sine, what's sine of, let's say, 60 degrees? Square root 3 over 2. What's sine of 120 degrees? Still has that same, these two triangles that I just drew both have the same sine value. Both of them work. And because that's between 0 and 180, and all the triangles in all the angles in a triangle add up to 180, we have to check for not just this solution. When you type sine inverse into your calculator, it will only find the answers that fit into quadrant 1. But because quadrant 1 and quadrant 2 are both less than 180 degrees, we have to take into account what I call the mirror angle, or the angle that's in quadrant 2 as well. So that's a long-winded way to say the ambiguous case. So 180 degrees minus the angle that we just found, which was 65.2 degrees, equals so 180 take away 65.2 ends up being 114.8. Now that's my possible other angle. That's my other possible B2. So then I would add on the given value. I know that I have to have 33 degrees included in my triangle. So I'm going to add 33 degrees from the givens. And we would get 114 plus 33 was 147.8 degrees. If this number is less than 180 degrees, then you have two triangles. Then you would have two triangles, which means I would come back over here to my chart and I would change these to A sub 1, B sub 1, and C sub 1s. That's my first possible triangle. And then I would make a second list called A sub 2, B sub 2, and C sub 2. Now all the givens are the same, so this is still 33 degrees. This is still 6. This is still 10. But we just figured out now that we have a possible another answer. 114.8 is a possible B2. All right, so that's a lot. That's a lot. That's a lot. Let me go back. Let's do this here. Let's come up with a way that we can write ourselves some notes so that I don't, look, this is not one of my favorite topics, but it's also something I'm not just going to skip because it's tough. So let's kind of try to come up with a way. Let's try to come up with a way to organize this idea of the ambiguous case. So the ambiguous case, we find the first angle. We find B. Then it's 180 subtract that first B. I'm going to call that B1. That gives us a possible, this is a possible B2. Now, how do we know if that's, then how do we know if it counts? If it's possible, how do we know when we want to include it and when we don't want to include it? We add on the given. And if we get a total that's less than 180 degrees, we get two triangles. Well, what if it's over 180 degrees? Well, then there's the second case doesn't work. And we would just go, we'd finish up the first case. By the way, I'm going to write that here. I don't want to spend my notes going through and finishing this. You can finish this on your own. Finish. We talked about how to finish that in example 1. So you would still finish these. You wouldn't be done with this example. But I'm not going to use my note time to do something that you already know how to do. Let's see. Actually, you know what? Let's go to our unit circle and let's add a little note about how we can do the ambiguous case. All right, so what would be a good color? I just did orange. Got some green right there, so I don't want to bump into that green. Purple? I guess purple. Just did purple. Yeah, we'll have to live with it. Okay, so ambiguous case. So in the ambiguous case, 180 degrees minus. All right, now we called this is B1. This is the first B value. That equals then a possible B2. And we know it's possible by checking, adding on the given. And when we add on the given, if we get something that's less than 180 degrees, then we have two triangles. If we get something that's bigger than 180 degrees, then you don't have to worry about the ambiguous case. You just go back and finish the first case. So let's try that. Let's have you pause here and see now that we've kind of talked about the ambiguous case. Look, at the end of the day, if you are like, I have no idea how the ambiguous case works. If you can still get this, you'll get 2 out of 3 points. All right. So this is going to be worth 1 point. This will be worth 2 points. And so if you are like ambiguous case is crazy, I agree. It's pretty tough. But I also don't think that it's something that we should be afraid of. So let's see if you can do it. Little a is 4.5. Little b is 5. Big A is 58 degrees. So now I'm going to set up, I'm going to first try to figure out what big B is. So sine of big B divided by 5 is equal to sine of 58 degrees divided by 4.5. I'm going to solve this using my calc. So I would take, I'm going to take 5 times the sine of 58, divide that by 4.5. Now I want to, I'll clear out and do that again just so you can see it better. 5 times sine of 58 divided by 4.5. Now I want to kill off the sine, so I do a sine inverse. I don't want to round yet, so I'm going to use the answer button, and I get 70.4. So big B is approximately 70.4 degrees. That's a done deal. If you want to go ahead and start to finish this, feel free. But that's done. I know that's correct. What I don't know is if there's a second case, if there's another possible way that we could do this. So now I'm going to do the ambiguous case. I'm going to check, I should say, the ambiguous case. So I'm going to look back at my unit circle. The ambiguous case is 180. Subtract the angle that I got, which was 70.4. That equals, so 180 minus 70.4 is 109.6. Now, that's a possible B2. I don't know if it's B2 yet. I have to add back on the given and see if I get something that's less than 180. So the given was 58 degrees. So 109.6 plus 58 ends up being 167.6 degrees, which is less than 180 degrees, which means I have, of course, 2 triangles. So then I'm going to go back here and I'm going to change all these to little ones. And I'm going to now make a new set of A sub 2, B sub 2, and C sub 2. The givens are still the givens. So 58 degrees, 4.5, and 5. But now I have a new possible, or that's not even possible anymore. I have a new value for B, which I'm going to call B sub 2. Now, I'm going to actually have you finish these. Let's go ahead and finish these, even though I said you didn't have to. I didn't want to do it up here, but let's do it at least once. So if I go back up to the first triangle, I would then do 180 minus. So 180 minus, I did plus, minus 58 minus 70.4 ends up being 51.6 degrees. Then I would set up a law of sines to find C sub 1. So I would do sine of 51.6 degrees over little c1 is equal to sine of, and always pick the one that they gave us, because that's technically not rounded. It probably is rounded, but they gave it to us, and we can assume it's not rounded. I'm not going to show my work here. I'm just going to solve this on my calc. So I would have to cross multiply. So I would multiply that up there, and I would multiply the 4.5 up here. So I'm going to go alpha F1. I'm going to multiply the 4.5 to the top, 4.5 sine of 51.6. And then I'm going to have to divide off the sine of 58. And I get 4.2. Now I'm going to do the same thing for C2 and little c2. So 180 minus, I did it again, 180 minus 58 minus 109.6 ends up being 12.4 degrees, small little angle. Now I'm going to set up a law of sines. Sine of 12.4 degrees divided by little c2 is equal to, and yet again I'm going to pick the one that they gave us, and I'm going to solve this on my calculator. So this time I'm going to do 4.5 times sine of 12.4, and then this is attached to C sub 2, so I'm going to have to divide off sine of 58, and I get 1.1. All right, there you go. So yet again, when do I have to do ambiguous and when don't? First of all, if they give you two angles, man, life is good because you could only have one other angle. Go, you're done. It's when they give us only one angle, we always have to do the ambiguous case when we find the next angle. I guess I should box in this one. All right, give it a try.